Module 11, I'm going to give you a choice to do one of two different projects, okay? And it can be based on, just how you're feeling about it or which one interests you more. Some people do them both and just submit one. It's up to you. And I'm going to give you some sample code to start with that will help you quite a bit because both of these projects require an external module that you're unfamiliar with right now. So I'm going to go over the projects one at a time and then show you some sample code that goes with each one. So the first one is a web spidering application. Basically, a web spidering application is something that's used all over the internet. That's what Google uses to go out and crawl through the whole web all the time, nonstop. Google is crawling through the web, making sense of pages, cataloging the text, and ranking them for the search engine. The way a web spidering application works typically is it's basically mimicking a web browser. It's mimicking the program you use on your computer to pull up web pages, and it's submitting things to a server just like when you click a link on a website, it goes to a server. So when we type in a URL in a web browser or we click a link, what that does is it sends what's called a request to the server. And that is the technical word. It's an HTTP request that basically says, I'm looking for this web page. If the server finds it and has it, then it sends back HTML code, which then is digested by your computer or your web browser. That code is what's used to display the web page. The web page itself is constructed on your computer. That's why if you use Microsoft Edge or Safari or Firefox or Chrome, it makes a difference as to what you can do. Sometimes web pages aren't compatible with websites and things like that because there are small differences. For the most part, they're the same in how they display the code, but there are small differences in each web browser. So what gets sent from the server to the computer, in essence, is HTML. And there's a few other code there, but we're just concerned with HTML today. Hypertext markup language is a code that's used to describe how web pages are supposed to look and the content of the web page. So if we learn how to take that HTML, which is just basically plain text, and make sense of it using Python, then we can look for links. So we can take a website, maybe like this one. If I went to www.website.com, I would see that homepage has two links on it that links to two different pages. And I could follow those links. And when I get to those pages, I can look at the HTML for those pages and see if that page has any links on it. And then I can follow those links and so on. That's literally what a web crawler or a web spider does. And that's kind of what we're going to be building, although in this case, it's going to be very simple. All we're going to do is keep track of what pages we find and how they're related to each other. And in the end of the assignment, what you want to be able to do is print out something like this that has the title of each page and the web address. And then underneath it, indented, the pages that link from that page, you're going to have the title and the web address. And then if there are pages that link from those and so on. What I have set up for you on my own web server is a test site that just has a few pages on it. So what you'll make sure that you do is you don't spider anything that doesn't start with that domain name. So it's going to be www.bmosley.com. So as long as you don't leave that domain, because there's a few offsite links to Google and that sort of thing, you don't want to start following that to Google and then spidering all the links there, because then your computer is just going to blow up on you because of the number of links. So you can write down, hey, there's a link to Google, but just don't follow that link. So there's some logic that you have to build in there. And so this is what the website looks like when you go to the URL. Pretty basic, not a lot of styling there. Small amount of HTML. If you look at the code, this is the code from it. What you're going to see in that code is the links. And so just like in assignment 8, where you recognize the email address is based on patterns in the text, you're going to use the patterns in the text here to grab those links. You're going to put them into a list, and then you'll keep track of which ones you visited, which ones you haven't. So you need to think about how can I create a data structure or a list or a dictionary or some combination of those things so that I can keep track of all of those websites, what I visited, what I haven't, what links, the titles, that sort of thing. Yep. Yep. Okay, so that's the first challenge. And so I'm going to show you really quick the sample text. This is already on Canvas, by the way, but we're going to be using URL library.request and SSL. SSL is for secure socket layer, so we can get into secure websites. And what we're doing with this Python code is we're impersonating a web browser. All of this part here is to set up the security so that when we get a security certificate from the website proving its authenticity, that it has a place to go. Because if we don't have a place for it to go, the website will reject us and know that we're not a real web browser. A lot of these other things where it says headers, and if you scroll to the right, you're going to see the word Chrome in here. This is actually impersonating a Chrome web browser. So when the server gets that request, it's going to say, oh, somebody's using Chrome to browse my website. Sure, I will send you the page. And then when it sends the page back, we read it and decode it and put it all in this variable, which we then print out. So this is the code that goes from having a web address as a string to printing out the contents of that website. And when I run this, you can see it takes a second, but there it is. There is the HTML code for that website in a string, printed out, and now I can just go through it and I can start looking for patterns. Okay. Nice thing about this is if I broke this into quote unquote words using spaces, I would look for words maybe that start with those 4 characters and know that that's going to be something that I can use. Another thing you could do, right, is look at this line right here would come back as one element of the array. Look what happens if I split this array on the quotes. If I use that to split it, then I have this part, which is garbage. I have this part, which is either garbage or maybe I want to parse that and use this piece here. But it's following the same pattern, so it'd be pretty easy. So, but what's left if I split it on the quotes is that the second element of that array is going to be the web address. Then I can just grab that. So sometimes things aren't as hard as they look. You just need to sort of look at them from a different angle. But this code will be what you will need to use. There are multiple ways to grab websites, multiple different tools in Python. This is the one that's most native to Python, the URL library request object. And SSL, this is pretty vanilla in terms of what it can do. There are some really fancy ones. There's one called Mechanize. And if you want to get into using Mechanize, you can. I'm just not going to support you if you get lost because Mechanize is a lot more advanced. But Mechanize actually allows you to do things like fill out forms on websites and do all kinds of crazy stuff. And I've used Mechanize quite a bit. This is just basic. It's just going to take that string, pull the web page, put the HTML there, then you can do whatever you want with it. So you might want to just put this code in a function where you feed it the web address and it sends back the HTML. That would be my suggestion to you. Okay, so looking at the second challenge for this assignment. The second challenge is to take your employee database and hook that thing up with permanent storage in a file. And you use it, so you use a text file to load the data when the program starts, and each time the data is changed, you'll save it back to the text file. This is trickier, and the reason it's trickier is because for the employee database, we're saving things in nested dictionaries. Now remember, when we did the last thing, when I showed you how to save a savings in a checking account balance, I just converted those to a plain text and I put one thing on each line. It was pretty easy to break apart. This has a lot more data and a lot more complexity to it. You could convert it to plain text using a special set of symbols and sort of thing, and then you could decode it manually. However, there's something that's much easier that I'm going to show you how to use. And this, again, this sample code is on Canvas. It's called pickle. And pickle in the sense of like pickling fruits and vegetables preserves them. So it's a way of preserving your data. Pickle actually takes a complex object like this dictionary with nested dictionaries in it and allows you to convert it to what's called binary code and save it to a text file with just a few lines of code and then bring it back straight into this format. It's really quite powerful and very, very useful for situations like this. So pickle, I'm going to use this nested dictionary here to show you how to use pickle. And I've got a couple of custom functions that I wrote. You're welcome. This one takes a dictionary object as a parameter, and it says, open this text file for writing in binary. That's what WB means. It's not Warner Brothers. Okay, so we're used to having the W. Now we're doing a WB. Pickle requires that because it does save it as binary code. If you do it with just a W, it's going to cause errors and issues. So you're going to open that WB for writing in binary. And then the pickle.dump method takes the object that you want to write, so the dictionary, and the file that we just opened, and puts it all in there. It just dumps it. That's why it's called dump. And then you close that file, and that's it. That's all it takes to save. Now, if I was going to take this dictionary and break it apart manually, it would take several nested loops and probably 30 or 40 lines of code to just convert that into something I could save in a text file. So Pickle does this in 3 lines of code for me. Super convenient. So sometimes we want to learn how things work. Sometimes we just say, I'm not going to reinvent the wheel. I'm going to use the wheel somebody else built. So loading the data, very similar. I'm going to open the Pickle text file for reading in binary, RB, absolutely necessary here. And then I'm going to say, create a dictionary object and put pickle.load from that file into there. And that's it. And it returns the database object. So when I want to use that, I'm going to say dfruit2 load data, and it's done. I could give it the name of the text file as a parameter, but I'm only using one text file. It's pretty straightforward here. So what this program does, now that I've created these things, is I've got saved data, and I'm going to pass it that array, dfruit, and then I'm going to load that data into a different dictionary so that I can prove that it's actually working. And then I'm just going to print that dictionary object, but it should be the same as dfruit1. In fact, for comparison, I'll print the first one. There we go. So I'm going to run that. And you can see it made a round trip to the file, came back identical. So that is amazing and convenient. And again, one of the best things about Python programming. If I open up that pickle file, this is what it looks like. You can see some names of fruit in here, so it's not all gibberish, but it's binary code. It's converted now to a different format. Well, not exactly, but sort of. I'm reading it as a text file, so it comes up a little weird. But this text file is actually what gets loaded back using Pickle. So you don't even have to worry about what that text file looks like or what it means or any of that stuff. For the purpose of this class and this assignment, just know that it works and be thankful that you don't have to do it manually, because doing it manually is a ton of work. Let me see if I have, where is that? I had some code, recursive crawler. No, that wasn't it. I yeah, I can't find it anymore. I don't know. I used to have a file where I actually did that, the manual conversion of things to a text file without using Pickle, but this is way better. So both of those things are in Canvas for you to start using. I would recommend maybe playing around with them. Um, if I had to choose one program that was easier than another, I think challenge number 2 is a little easier, just as far as wrapping your mind around it and the complexity of it. I think it's fairly simple. Most of the code you've already written, so you just need to take that pickle code and implement it there. Challenge 1, very interesting and could be useful to you in the future. So if you want to try playing around with that, that's a good thing to do too. So you do have a choice. You only have to do one, but if you want to play around with both, they're both there for you. And yeah, I think that's it. Any questions? Okay, cool.